Good morning to one and all. Myself, D.S. Gordhan. I am from Electrical Electronics Engineering branch. My topic is about conversion of Cartesian coordinates to spherical coordinates in electromagnetic fields. First of all, cylindrical and spherical coordinates. These are the block diagrams of cylindrical and spherical coordinates. And next objectives: discuss the cylindrical and spherical coordinates, solve the cylindrical and spherical coordinates in Cartesian coordinates and vice versa, develop patience and teamwork with their partners in answering different problems of cylindrical and spherical coordinates. Next, it is in spherical diagrams of some of the places, and cylindrical coordinates. It is the block diagram of cylindrical coordinates and cylindrical coordinates. The cylindrical coordinate system is an extension of polar coordinates in the plane to three-dimensional space. The cylindrical coordinate system. In the cylindrical coordinate system, a point P is space is represented by an ordered triple r theta z. R theta is a polar representation of the projection of P in the xy plane, and z is the directed distance from r comma theta to P. And next, to convert from rectangular to cylindrical coordinates or vice versa, use the following conversion guidelines for polar coordinates as illustrated in figure 11.66. Here we can see rectangular coordinates: x is equals to r cos theta, y is equals to r sin theta, z is equals to z. And in cylindrical coordinates, r square is equals to x square plus y square, tan theta is equals to x by y, z is equals to z. And next, cylindrical to rectangular: x is equals to r cos theta, y is equals to r sin theta, z is equals to z. Rectangular to cylinder: r square is equals to x square plus y square, tan theta is equals to y by z, y by x, and z is equals to z. The point 0 comma 0 comma 0 is called the pole. Moreover, the point 0 comma 0 comma 0 is called the pole. Moreover, because the representation of a point in the polar coordinate system is not unique, it follows the representation in the cylindrical coordinate system is also not unique. Convert the point r comma theta comma z is equals to r 4 comma 5 pi by 6 comma 3 to rectangular coordinates using the cylindrical to rectangular conversion equations produces x is equals to 4 cos pi 5 pi by 6. These are the calculations of x comma y comma z. So in rectangular coordinates, the point x is comma y comma z is equals to minus 2 root 3 comma 2 comma 3 as shown in the figure 11.67. And next, these are example. For example, find the cylindrical coordinates of the point 1 comma 2 comma 3 in Cartesian systems. Solution: from the given points we get x is equals to 1 and y is equals to 2 and z is equals to 3. Substituting these values in cylindrical coordinates, we obtain, while changing cylindrical coordinates to Cartesian coordinates, we have to use tan theta is equals to y by x, then theta is equals to tan inverse 1, tan inverse 2, theta is equals to 63 degrees 23 minutes and 5.8, and r square is equals to x square plus y square, r is equals to root of 1 square plus 2 square, that is equals to r is equals to root 5. Thus the cylindrical coordinates of point 1 comma 2 comma 3 is equals to root 5 comma 63 degrees 23 minutes 5 comma 8. And next, cylindrical coordinates. Cylindrical coordinates are especially convenient for representing cylindrical surfaces and surfaces of revolution with the z axis and the axis of symmetry as shown in the figure 11.69. Here we can see the block diagrams of cylinder, paraboloid, and cone, and hyperboloid. These are the formulas for using the in problems. And next, cylindrical coordinates: vertical planes containing the z-axis and horizontal planes also have simple cylindrical coordinate equation as shown in the figure. And next, spherical coordinate: x comma y comma z. This is spherical coordinates block diagram. Next, spherical coordinates. In a spherical coordinate system, each point is represented by an ordered triple. The first coordinate is a distance, and the second and the third coordinates are angles. This system is similar to the latitude longitude system used to identify points on the surface of the earth. Spherical coordinates: for example, the point of the earth surface on the of earth whose is 40 degrees and longitude is 8 degrees west of the prime meridian in figure. Spherical and has a radius of 4000 miles. You Next, the spherical coordinate system. In a spherical coordinate system, a point P is in space is represented by an ordered triple: theta comma pi comma p, where p is the lowercase Greek letter rho and pi is lowercase Greek letter phi. And next, rho and phi. Rho is the distance between P and the origin. P rho is greater than or equal to 0. Theta is the same angle used in cylindrical coordinates for r is greater than or equal to 0. Phi is the angle between the positive z axis and the line segment OP. And 0 is less than or equal to phi, less than or equal to pi. Note that the first and the third coordinates rho and pi are non-negative. And next, spherical coordinates. The relation between the rectangle and spherical is illustrated in figure 11.75 to convert the one system to the other. While changing from rectangular to spherical, we use x is equals to rho sin theta cos theta, y is equals to rho sin theta sin theta, z is equals to rho cos theta. Rho square is equals to x square plus y square plus z square, tan theta is equals to y by x, pi is equals to ar cos z by root of x square plus y square plus z square. And next, spherical coordinates. To change coordinates between the cylindrical and spherical systems, we use the following formulas. Spherical to cylindrical, r square is equals to rho square sin square phi, theta is equals to theta, z is equals to p cos phi. Cylindrical to spherical, r is greater than or equal to 0, rho is equals to root of r square plus z square, theta is equals to theta, phi is equals to ar cos z by root of z square plus r square. Spherical coordinates. The spherical coordinate system is useful primarily for surface space that have a point or center of symmetry. For example, figure 11.76 shows three surfaces with simple spherical equations. And next, example converts 4 comma pi by 3 comma pi by 6 from spherical to Cartesian coordinates. You can use from the given point and we obtain Cartesian coordinates. By following the formulas, we get the Cartesian coordinates are 4 comma 5 pi by 3, pi by 6 is root 3 comma root 3 comma 2. And next, example to for rectangular to spherical conversion. For an equation in spherical coordinates for the spherical represented by rectangular equation, a cone x square plus y square plus z square, sphere x square plus y square plus z square minus 4z is equal to 0. Use the spherical to rectangular equations. X is equals to rho sin pi cos pi, y is equals to rho sin pi cos sin pi, z is equals to rho cos pi, and substitute in rectangular equations as follows. Here the solution. So conclude that pi is equals to pi by 4 and pi is equals to 3 pi by 4. The equation pi is equals to 3 by 4 and pi is equals to 3 pi by 4 represents. And example 5 is solution. And example. Thank you.